Okay, I think we're here. Are we live? Jim?
Yes, Robert, we are live.
Okay, well, then we're live. So,
I
everyone,
would wait. I would just wait for a moment, Robert.
it's okay, he's here. I won't.
Yeah, right here.
Okay, perfect.
Okay, so, well, Elon, you need no introduction, but for those who don't know, you are the founder and chief engineer of SpaceX and a longtime friend of the Mars Society, and we're delighted to have you back. We've got 9,000 people registered to hear you today.
All right, cool. Sounds good.
Okay, so
I should change this perspective. Let's see if I can change the perspective. Is that better? Or is that worse?
I think you were better before.
Okay.
Okay, so listen, why don't we just start out with the basics? You started SpaceX to make humanity multi-planetary.
Yeah.
Why do you see that as a critical goal?
Yes. I think we want to be on track to become a multi-planet species and a space-faring civilization in order to find out what the universe is all about, like what, and ensure the continuance of consciousness as we know it. As far as we know, we're the only life. I mean, people think there's aliens, but honestly, I haven't seen any sign of aliens. So as far as we know, we're the only life. Whether we could be the only life, so let's put it that way. And we need to take the set of actions that are most likely to make the future good and result in the continuance of consciousness as we know it.
Okay, so well, obviously your means to that end is to open the space frontier with reusable launch vehicles, and you've gone through some partially reusable ones, and now it's Starship. Can you explain basically the line of thinking that led you to the Starship design?
I forget what I need to look at to look like I'm looking at the camera. So let's see. Well, on the Starship front, we've gone through many iterations, starting from not really knowing how to build rockets at all with Falcon 1, and having 4 failures actually in reaching orbit. 3 failures, and then the 4th one got to orbit. So 4th one's a charm. So we only barely survived. I was at 0 cash basically when we got that 4th one to orbit, and if that 4th one hadn't worked, we would have been curtains. So it's definitely not been smooth sailing. It's been a very difficult ride, with just a lot that has been discovered along the way. I mean, just trying to figure out what questions to ask about the design was quite difficult. I think it's helpful to have as the objective the creation of a self-sustaining city on Mars. I think this has to be the objective, not simply a few people or a base, but a self-sustaining city. The acid test really is if the ships from Earth stop coming for any reason, does Mars die out? For any reason. It could be banal, or it could be nuclear Armageddon. It doesn't matter. If the ships stop coming for any reason, does the city on Mars die out? If it does, we're not in a secure place. So, I mean, I think this really might come down to, on the great filter front, are we going to create a self-sustaining city on Mars before or after World War III? And I think the probability of it being created after World War III, hopefully there's never a World War III, but of after is low. So we should try to make the city self-sustaining before any possible World War III. This is just a risk. This is not, I think sometimes people have difficulty dealing with probabilities. It's either this way or that way, but it's really, we just face a series of probabilities. And there's some chance that we will have a giant war or a super volcano, or a comet might hit the Earth, or we might just self-extinguish in some. It might be more of a whimper than a bang. And frankly, right now civilization is not looking super strong. It's looking a little rickety right now, to be frank.
Would you
So-
say that it's more than a lifeboat, that it would actually make human civilization more robust, clearly more able to divert asteroids from hitting the Earth and otherwise help?
Yeah, it's not an escape vehicle. It's simply something that it's not like you can. I mean, unless Mars is made self-sustaining, which will probably not happen in my lifetime. It is certainly not. It's meaningless to have an escape, lifeboat or escape hatch or something, if you're simply moving to another place where you will soon die out. That doesn't count. It's not much of a lifeboat, really. So this is really about, say, minimizing existential risk for civilization as a whole, and then having an exciting future that you can look forward to, and a future where we are a spacefaring civilization and multi-planet species is far more exciting than one where we are not. I mean, that's an exciting future, and being forever confined to Earth until some eventual extinction event is depressing and not fun. And we need things that make you want to get out of bed in the morning and be excited about the future. And I think being a spacefaring civilization is one of those things that everyone can get excited about.
But can you maybe just kind of lead people along the path that led you from the design of, from Falcon 9 to Falcon Heavy, but now Starship is rather different than Falcon Heavy.
Yes,
the engineering.
Absolutely. Absolutely. I didn't quite answer your original question. You first have to say what is the goal, and once you have what is the goal, you can then measure various designs against that goal. If otherwise, you're saying, how are you evaluating? Why is one design better than another? What's your goal? It's got to be a goal. So the goal is get enough tonnage to Mars and enough people to make Mars self-sustaining as quickly as possible. So then you say, okay, let's back out the math on this. We're gonna need a lot of tonnage. Maybe, I don't know, 100,000 tons, maybe 1 million tons. So you can't be faffing around with these expendable rockets. They're a joke. They're absurd. Even Saturn V is tiny potatoes. We need it, because if you want to get, let's say, first order approximation, 1 million tons to the surface of Mars, inclusive of people, that means probably something around 4 or 5 million useful tons of payload into low Earth orbit. For every time you get to low Earth orbit, you're going to get 4 or 5 tons, hopefully closer to 5. This math is you really start squeezing like tiny percentages. But let's say confidently, if you got 5 tons to low Earth orbit, you can get 1 ton to Mars. That's confident. Maybe you can get, maybe you only need 4. Anyway, the point is, you need 5 million tons into Earth orbit to get 1 million tons to Mars. Now, let's put this into perspective. Total global capacity to orbit of all expendable rockets is around 500 or 600 tons, I think. And if you said, okay, the world's going to end if you do not increase your capacity, perhaps they could do 1,000 tons. Okay, so that's 1/5000th of what's needed. This is ridiculous. It's not even, 0.1% would be 1,000th. So way less than 0.1%. We have way less than 0.1% of the capability needed to create if everyone went full tilt with expendable rockets. Expendable rockets are just utterly stupid, in my opinion. Utterly stupid. They're a complete waste of time. People should stop wasting their time. If you try to sell an expendable plane, people would laugh you out of the room. If you try to sell an expendable car, they would laugh you out of the room. If you try to sell an expendable horse, they would laugh you out of the room and think there's something wrong with you mentally. So all these things are reusable. It's essential to be reusable. Now, creating a reusable rocket, orbital rocket, is very difficult. Doing a suborbital reusable rocket is easy. Doing a reusable orbital rocket is hard. Even when a lot of smart people have put quite a bit of effort into it, they might get 2 or 3% of the lift-off mass to low Earth orbit. And a really epic rocket would get 4. I'm not sure, I don't think anyone's ever gotten 4. But you basically need to have something that in expendable form would probably get about 4% of its payload to orbit, such that you can spend about half of that 4% on reusability and still net out to around 2% of payload to orbit. So you have to make both the booster and the upper stage and the fairing and everything reusable. With Falcon 9, so with Falcon 1, we did actually attempt to do this. So we had a parachute from the first stage, but really did not appreciate that that first stage was going to hit the atmosphere like a concrete wall. So at first I got pretty mad at the parachute supplier until I realized, it's not their fault. We were just big fools. That thing was exploding as soon as it hit the atmosphere. So you really got to do something to ease the transition into the atmosphere at high Mach number. It's very hot and there's a lot of force and a lot of heat. So then with Falcon 9, we made a bigger rocket, and that scale matters here because you do get basically economies of scale. You can't have a tiny rocket. There's a tiny rocket, you basically just end up carrying your electronics to orbit. So your avionics, So in a little rocket, if you're small enough, just your avionics alone ends up being a significant percentage of your payload, and then you end up, if you had a rocket that was, I don't know, trying to get a 10,000 pound rocket, for example, or even a 10,000 kilogram rocket to orbit, I think you would basically get 0 payload. Now, as you get bigger, the rocket gets bigger, but the brain doesn't get bigger. The brain can stay the same size. So your avionics, for example, become almost 0% of the weight for a big rocket. Then for big rockets, you also get gauge advantages. So we're really in the nuances of rocket design and manufacturing here. If things are very small, it's difficult to get your gauge accurate. Basically, how thick is the material? Like you want to do castings, for example, there's a minimum gauge or thickness for a casting. There's a minimum kind of error bar on the material skins. Even for a composite rocket, you've got you start hitting granularity issues. As you get bigger, you're no longer gauge limited, and you can get your percentage accuracy on the thickness of walls and castings can be very good. These are nuances that I think almost no one appreciates, but suffice to say that there are advantages to size. And you can certainly see this in many walks of life where if you've got a truck that's carrying cargo, it's more efficient to have a big semi-truck, not a bunch of little trucks. For ships, it would be pretty silly to see container ships or containers going across the ocean one at a time with little outboard motors. That would be silly. You put them on a container ship. You have big ships, not little tiny ships. So anyway, so size matters, it really does. And full reusability matters. So with Falcon 9, after immense effort, we were able to achieve reusability of the booster. And we're mostly achieving reusability at this point with the fairing as well. But this is a monumental effort. And I think within its architecture, Falcon 9 is close to a local maximum. If you say, gas generator cycle, kerosene, oxygen vehicle of this particular size with a 12-foot or 3.6 meter diameter, which is that size because of road transport limitations. So if you go bigger than that, you can't transport it over the road, and your logistics costs become extreme. So, but having a long, thin rocket is not very mass efficient. You end up having to have thicker skins to take out the bending moment. And then having, like, kerosene is not the right fuel. Methane is a much better fuel. You can get higher ISP, a specific impulse, basically efficiency. I mean, for those who, I think probably a lot of those who are listening know what the rocket equation is, but in simple terms, it's actually very simple. It's like a rocket is going to go further if it shoots the gas out of the end faster, and if a bigger percentage of its mass is propellant. It's obvious. So that's what the rocket equation says. So shoot gas out faster in the right direction, and increase the propellant, the percentage of propellant that's going to allow you to go further. With methane, you can shoot it out faster, and you
can make it on Mars.
You can make it on Mars for sure. Exactly. So being able to do in situ propellant development or production is very important. So you don't have to carry your return fuel with you, or return fuel and oxygen. It's to be like rockets are mostly oxygen or oxidizer. So and there's some other subtle advantages with a oxygen methane system, in that you can go to a higher percentage, a higher mass ratio of oxygen. So with kerosene, you'd be at about roughly 2.5 to 1 oxygen to fuel mass ratio. With methane, you're more like 3.5 to 1, and you actually want that higher mass ratio because oxygen is very dense and it's inexpensive, especially on Earth. So you're gonna, you have all these plants just making oxygen all day long, and plankton just making oxygen, never do anything. So the cost of oxygen is basically the cost of electricity. Anyway, so going from Falcon, going from kerosene, which is basically the same as jet fuel. It's like RP1, rocket propellant grade kerosene, is just a tighter grade of jet fuel. You want to go from that to something which has where the gas shoots out faster, and that's methane, and where in situ production of propellant is easier. So that's why the change from kerosene to methane. Methane is just CH4. It's 1 carbon, 4 hydrogens, and then the oxygen pairs together. So you have it's called O2 because oxygen pair bonds. And obviously, you know all this stuff. I'm just basically
so that kind of
for the audience
together. Large size, twice the takeoff thrust of a Saturn V, but about the same payload. But that gives you reusability, much cheaper, in situ propellant. It all is coherent. And so let me ask you the thing that I think everybody wants to know, which is when. When are we going to see Starship do a high flight to the stratosphere? When to orbit? When first payload to Mars? When first humans to Mars? All right.
Well, it's not like we're obviously venturing into unknown territory, so it's not as though I have all these secret dates and I'm just keeping them from people. But these are just guesses, obviously. I'm 80 to 90% confident that we will reach orbit with Starship next year. I think probably 50% confident that we'll be able to bring the ship and booster back. That's more of a dicey situation. We'll probably lose a few ships before we really get the atmospheric return and landing right. We might lose. Hopefully, we don't lose it. Hopefully, we don't lose any boosters, because that's a lot of engines. Our initial booster flights will just have maybe 2 to 4 engines, not 28. 28 is a lot of engines. So, and then I think we'll probably be in doing high volume flights. I think probably in 2022, so a couple years from now. But I'm trying to make sure that our rate of innovation increases, it does not decrease. This is really essential. In fact, if we do not see something close to an exponential improvement in our rate of innovation, we will not reach Mars. Like a pure linear doesn't get there. Well, I'll be dead anyway before it gets there if it's pure linear. If it's exponential, I think we could get to Mars. We could probably send an uncrewed mission there in maybe 4 years. There's a Mars conjunction every 26 months. There's one this year, so that means in a couple of years from now there's another one, and then 4 years from now there's another one. I think we've got a fighting chance of making that second Mars transfer window.
So one thing that is really amazing about SpaceX, to those of us who have experience in the aerospace industry, is the rate of innovation. Last time you spoke to the Mars Society Convention was 2012. Since then, you've made the Falcon 9 reusable, introduced Falcon Heavy, the Crew Dragon, a satellite constellation, and you're in the middle of developing Starship. What is your, what would you say is your methodology that allows you to innovate so swiftly?
I don't really know. We're focused on, like I said, it is important to have the objective be right. That's why I was talking so much about the importance of making Mars a self-sustaining, building a self-sustaining city on Mars. If that's the objective, then obviously, just putting some satellites in orbit that's not important. You have to achieve full and rapid reusability. I emphasize full and rapid. Reusability is only relevant to the degree it's rapid and complete. And then you also have to do orbital refilling. This is essential as well. And then propellant production on Mars, also essential. So, with that as the goal, then that means that creates, I think, a good forcing function for radical innovation, because in the absence of radical innovation, we have no chance of meeting that goal. Whereas if our goal was simply, defeat Lockheed and Boeing or something like that, that we would probably achieve. You've already done it. That really wasn't even a thing, Yeah. I wish it was. They're not really not even trying to do reusability, which is bizarre because they make planes that are reusable. So, I mean, if they talk to if they talk to one of their customers, buy us a Lockheed fighter jet or a Boeing aircraft, like, hey, we're going to sell you a 737 that can be used once, and it's not 737 Max. But that turns out that was a single-use airplane at times. But it really. It would be an absurd thing for them to sell a single-use aircraft, but they feel quite comfortable selling a single-use rocket. And anyway, but if our goal was simply we're going to be the leaders in launching the conventional satellites that exist, we would probably approach that on a sort of a logarithmic basis, where you'd get there and you'd sort of slowly make progress towards doing 10 launches a year, 12 launches a year, and while they do 6 or something like that. I don't know. But since the goal is, hey, we need to make life multiplanetary before it's too late, and time really matters. So it's like we're shooting for Mars, not just the moon. It's not let's shoot for the moon, shoot for Mars. And then these competitive things are kind of small things along the way. Unless somebody else is shooting for Mars, they will not be competitive with something as pedestrian as launching a few satellites into Earth orbit.
So how can the Mars Society help you?
Well, I do think there's, in order for there to be a self-sustaining city on Mars, we're going to need an intersection of sets here. One set is the set of people that want to go and can either find sponsorship, they can either afford it themselves or find government sponsorship or take out a loan or whatever the case may be. But somehow you've got to have the set of people who want to go to Mars and can come up with the funds somehow to do that. And then it's I should say there's two sets: desire to go to Mars and can afford to go to Mars. When desire to go to the people who want to go to Mars, and the people who could afford to go to Mars, when that intersection of sets reaches 1 million, roughly, then I think we will have this city on Mars. So we need both the motivation and we need both the means and the way. I mean, it's like we need people to want to
The
go.
will and the way.
The will and the way. Yes, exactly. The will and the way. Well, there's a will, there's a way, but in this case, we need will and a way. So when the will and the way intersect, then we will be a multi-planet species. The will and the way must intersect. So I think the Mars Society can really help with the will.
Okay, you provide the way, we'll provide the will.
Yes, exactly.
Okay. Now, your assistant Jen told me earlier that you have a hard cutoff at the half hour. Is that true, or do you want to stay and take some questions from the audience?
Yeah, we could do maybe 5-10 minutes of questions.
All right, great. So we've got hundreds of questions. So Jim, do you want to read a question or two?
Yeah, sure thing. Hi, Elon. My name is James Burke. I'm from Seattle, Washington. Where's the best place to land on Mars, do you think?
Yeah, actually, I'm not super sure. I can tell you what the criteria are that you'd want. You'd want to be. Anyway, I think the short answer is mid-latitudes, probably on the north. So you want to be close to ice. You don't want to be too you don't want to be too far away from the sun, so you can get solar power, and you want to land at a low altitude so that you can take maximum effect of atmospheric braking. What do you think?
I like Melas Chasma. It's a nice little area at the bottom of Valles Marineris. The air pressure's high.
Okay. Is there a lot of ice there?
There's ice around there. We'd have to look for it, though.
Okay.
That kind of brings me to my next question, and then I'm going to turn it over to Carrie to ask you one. How would you prioritize like missions like 2 through 10? Are you going to focus on exploration or building up the infrastructure or science?
We're going to, I think the first order of business is build a propellant plant. I mean, we can for sure lob out a bunch of droids, that's no problem. I think why not? We're going, and probably if anyone wants to put their droid on, we could just take it. And, it's like, hey, it's basically a remote control car, a solar powered remote control car. And we could provide the communication relay. So, you could just basically connect to your car from your computer at home and cruise your electric. You could have legs too. It doesn't matter. Your robo device / car. That would be pretty cool. There's a lot of people worried about life contamination. It's like, listen, anything that can survive on Mars is so freaking tough. It's insane. That it is cold and there's like a lot of UV radiation, and it's not going to be too worried about anything we send from Earth. Let me put it that way. It's just tougher than anything on Earth. But I think the first order of business is we've got to build a plant to make propellant, and so we've got to need a lot of energy. We've got to mine some ice, and you got CO2 from the atmosphere. So from the ice, you got the H2O. Combine the H2O with the CO2, you get CH4 and O2. But that's a lot of energy, and it'd be quite hard, I think, to make that propellant plant reliable. But that's the primary order of business, and then we could also look around and see if we can learn anything from a scientific standpoint.
Carrie, do you want to go next?
Sure, thank you, James. I'm Carrie Fade. I live in Denver, Colorado. Thank you for joining us today, Mr. Musk. We do have a lot of questions from 13, 14-year-olds. So I'm just going to pick one and ask you. It's from a teenager, and her name is Dara. And she wants to be an engineer and build starships and robots. And her dream is working for SpaceX. What should she focus on to be an engineer?
Well, I think there's all kinds of engineering that's needed. So you don't have to be an aerospace engineer. You could be in electronics, mechanical engineer, electrical engineer. You could be software engineer. I mean, there's a lot of engineering, basically almost any kind of engineering. We'll need chemical engineering, I think, also for figuring out how to make a good propellant depot, or I should say propellant production plant. Yeah, I think physics in general is a good background for thinking. I just generally recommend people take physics courses because physics has the best tools for critical thinking.
Thank you, Elon. James?
Yeah, thanks, Carrie. Another question. The Boring Company. Now, is that just kind of an outfit to build tunneling machines that can work on Mars?
No. The Boring Company actually started as kind of a joke. And for a lot of times people would ask me, what do I think the opportunities are out there? And for, I don't know, 5 years or more, I kept saying, can someone please start a tunneling company? Because I think tunnels have a lot of opportunity for alleviating traffic in cities and just improving quality of life overall. I mean, there's a lot of streets you could turn into parks. Certainly you wouldn't need parking. You could just park cars on the ground. So, and everyone thought I was joking. And I was like, well, I guess we'll see what it takes to drill a tunnel, dig a tunnel, and all these like so-called traffic experts and haven't really made much progress. Cities like LA and DC are still a traffic nightmare. I'm like, okay, guys, well, if you got such great ideas, why is this still a traffic nightmare? So if you build tunnels, you got to go 3D somehow, either underground or above ground, like either air or ground. And the problem with air is like, anything that can carry a person is going to generate a lot of noise and a lot of wind force. So, and could fall on your head, and also kind of not be good for privacy. And you're sitting in your backyard and someone like flying over you is like not that cool. So, but tunnels are working all those things. They're also weatherproof. Don't have any privacy issues and safe. And anyway, they would make a big difference to traffic. And we have the first production tunnel or useful tunnel in Vegas that's going to open, I think, in a month or two. So a few months, I guess. And hopefully we'll be ready for prime time around the Consumer Electronics Show. Now for Mars, I think tunnels and digging in general is good, but you need to build a very light system compared to what would matter on Earth. You don't really care all that much about mass on Earth. You care a lot about mass going to Mars.
Is it fair to say that you're learning some techniques that might apply to Mars with the Boring Company?
Yeah, probably.
When do you think Starship will be able to be demonstrating refueling in low Earth orbit?
I think we've got a shot at doing that in 22, about 2 years.
And then when do you guys think you'll have a moonship prototype?
Probably 2 or 3 years. As soon as you've got orbital refilling, you can send significant payload to the moon. Like significant meaning 100 tons of useful payload at a shot.
So then from there, I think you mentioned Mars is a couple years after that.
It's only a couple years after that because the Mars transit window is every 26 months. I think we maybe have a shot of sending, or trying to send something to Mars in 3 years, but the window is 4 years away because of being in different parts of the solar system.
Carrie asked a question from a young person. I'd like to also ask, do you have any tips for young people who love Mars but don't know how to help with the settlement of Mars?
Well, I think definitely, anyone who is a strong advocate for Mars, I think this really makes a difference. A lot of times it's not even, people aren't even thinking about it. And, you can talk to people at a party or talk to friends and like, it's just not even a topic of conversation. So I think it could really help if everyone out there who thinks this is important for the future of humanity and consciousness as a whole, to make it part of what people are thinking about. Bring it up at parties and talking to friends and online. It's like, it should be a thing that we do. And I think it's worth, maybe 1% of our resources at least. And that's not going to fundamentally change things, quality of life. If we spend 1% of our resources, much less than healthcare, obviously, maybe probably even less than we spend on cosmetics, frankly, then that would be enough to make life multiplanetary. But we really need to make this a thing people talk about at least 1% of the time, and that would really matter. As we were talking about earlier, we need the will, which is we need a critical mass of people wanting to make it happen, and then we need the way. And SpaceX is going to try hard to provide the way, and then once we show that there's a way, probably there'll be other companies that also try to do it as well. So we need the will and the way. They can provide either. The will is extremely important. It makes a huge difference.
What's the coolest part of Starship development?
Well, I guess the coolest part of Starship development is working with just a great team of engineers and coming up with interesting solutions. I think it's just fundamentally enjoyable if you're working with a lot of good, smart people creatively towards solutions that have never existed before. That's very rewarding. So I guess probably I like that the most.
Can you talk a little bit about how Starship can be used for other destinations in the solar system, like Venus and the outer planets?
Starship is definitely a generalized ship. It basically it solves for transport anywhere in the solar system where there is a solid surface to land. So if you can land there, we're going to take there. We'll also actually go into the atmosphere of Venus, for example, just like go into orbit and perhaps to the upper atmosphere. Venus's atmosphere is extremely dense, also quite hot. But because of that dense atmosphere, you could have something. You could have a kind of like some sort of dirigible. Some kind of like things that could float on Venus that could not float on Earth in the atmosphere because of the dense atmosphere. So you could go to Venus. I mean, it's not a super friendly place. And then like Mercury is super hot. I think that we could go to Ceres or any of the asteroids, the moons of Jupiter, although there'd be quite high radiation around there. And then out to Saturn, eventually getting out to, the sort of Kuiper belt or cloud and that kind of thing, the outer solar system. So Starship, once you have propellant depots, you can kind of like planet hop or moon hop around the solar system. It's not a vehicle that would enable us to go interstellar, but it's that's a tough one. But we need to make the leap of going to another planet first. Once we are a multi-planet species, we will create a forcing function for the rapid improvement of space flight, and we'll figure out new technologies that will ultimately allow us to go to other star systems.
What do you look for in the people you hire, especially the engineers?
Really just look for evidence of exceptional ability. So it's not, or at least aspirationally, like sometimes these things get messed up in recruiting, or the recruiting filter ends up being wrong. Like I sometimes wonder with Tesla, if Nikola Tesla applied to Tesla, would we even give him an interview? It's not clear. This guy came from like some weird college somewhere in Eastern Europe. He's got some odd mannerisms. Now we don't know if we should give him an interview. Like I worry that that's actually what we do instead of like, right? It should be like, man, Nikola Tesla, this kid's super smart. What does he want? We'll pay him anything. That should be that should be the reaction if Nikola Tesla applies, to Tesla, ironically. But I can tell you the intent is we're looking for evidence of exceptional ability, and it really doesn't matter if you went to graduate high school or college or anything. We're just looking for evidence of exceptional ability, such that it would be a good predictor for doing exceptional things at SpaceX.
All right. Do you have some more questions from the audience there, Jim?
I've got one. So have you thought about communication networks between Earth and Mars and you're working on Starlink. What about like an internet around Mars? Have you thought about that?
Yeah, you could certainly do some variants of Starlink. This will probably have to be the last question because I've got a bunch of things piled up. But yeah, you could just do a version of Starlink around Mars, and then you just need a big laser coming from Earth. Probably want it to be in orbit so it doesn't get atmospheric diffraction or attenuation. You want to go from a big laser from Earth orbit to Mars orbit, and then you're going to need some relay stations for when Mars is on the other side of the sun. So you can't just shoot a laser through the sun. All right, thank you.
Thank you so much, Elon. We're all pulling for you. Good luck.
Yeah.
All right, much appreciated. And just like a thank you to all the people out there that are fighting hard for the cause of Mars. There's not that many, and we need more. Thank you.
All right, thank you.